We are live once more, and today's conversation is about using artificial intelligence for good. So we'll be live here on LinkedIn, but also on YouTube, and we will turn this into a podcast episode. And what we want to look at today is some amazing examples of using artificial intelligence to make our world a better place and address some of the biggest societal challenges we face today. We're going to explore the ideas and dreams that motivated the people behind these technical challenges, and behind those technical innovations, and why their work matters and how AI helped them to address these challenges. And to do this, I am very pleased to say I am joined here by three amazing AI pioneers, experts, who have used AI to make a real difference. So I'm joined by Hadas Bitran from Microsoft. You are based in Israel, is that right?
That is correct.
Yes, very good. And then we have Dr. Greg Bowman, a COVID-19 grantee from the USA. You are in St. Louis in Missouri. You're joining us, is that right?
That's right.
Perfect.
Yes, it's a pleasure.
And then we have Alice Peterova, who works for AI for Good in the UK. You're based here now in the UK, but you're originally from Russia. So welcome. We have a lovely international panel here, as always. And these sessions, as always, are for the people watching, listening. They want to learn. They want to hear interesting stories, and hopefully we can deliver this today. As I said, if anyone wants to re-listen to any of those conversations that we're having, you can head to my YouTube channel where you can see all the recordings. I'm just having a little look through the stream. We've got people joining from Tunisia, from Nairobi, from Iran, from Peru, from all across the UK, all across the US, from India, from Jordan. So it's lovely to see all of this. And we're missing one person. We're missing Kelvin Sumogun from My Care in Mauritius, and hopefully Kelvin will be able to join us soon. So let me start with you, Hadas. What motivated you to work on your project, and can you give us a brief overview of what you're working on and maybe why it matter to you so much?
Thank you, Bernard. So I was looking to create technology that helps humanity, technology that addresses real problems in healthcare, that improves humans' lives. The healthcare system, healthcare always mattered to me, and the healthcare system is so overburdened that I wanted to help. I work for an organization that drives health AI products, and my group is focused on healthcare language services. We build conversational AI technologies, chatbots, and NLP technologies that specialize in the healthcare and biomedical space. Why does it matter? Our technology puts more information in the hands of patients. It allows learning from existing data that may even power medical research breakthroughs. It allows improving processes and reducing burden from the healthcare workers. During the COVID-19 beginning, we helped power more than 2,000 health bots in just a few weeks all around the world that helped more than 30 million people, providing them information, symptom checking capabilities. My hope is really that our technology will also improve healthcare outcomes eventually.
Wonderful. Yeah, for me, healthcare is probably one of the best use cases for AI, where it can make a real difference, where it can give many more people access to healthcare. So my hope is that AI will make a real difference there. So very good. How about you, Greg? What's your what and why? Why did you embark on your project? What you're working on and why?
Yeah, well, pleasure to be here. So thanks. And so I really got motivated initially by losing much of my vision as a child due to inherited retinal degeneration disease. And what I came to learn is that the root cause of my vision loss was really the malfunctioning of a molecular machine called a protein. And it's not clear how this thing is supposed to work and how it malfunctions. And in particular, it's not clear how to go in and fix this molecular machine to prevent it from malfunctioning or restore proper function. And so I got really fascinated by the idea of understanding how proteins function and malfunction and how we can use that to accelerate drug discovery and especially using massive computer simulations to get at information that's otherwise inaccessible. And AI really came into the mix because we have this globally distributed computing with now over 1 million people helping us generate data. So it's a huge, massive data that we need to be able to comb through to extract insight from, and automating that using machine learning and AI is proving extremely valuable.
Wonderful. And next one is Alice. What are you working on, and what motivated you to work on what you are working on?
So in essence, we are working on a web tool for charities and NGOs working in refugee camps, also local grassroots organizations working with refugees. The idea is to model the potential spread of coronavirus in a high-density, low-income setting and displaced populations, so such as refugee camps or internally displaced people camps or urban slums even. The simulator is designed to help organizations to prepare timely and proportionate response to the pandemic, and also kind of like mitigate the worst possible scenarios, obviously. What motivated me, to be honest with you, I'm an immigrant myself, so I moved to the UK like 7 years ago. And I'm still kind of adjusting. And to be honest, it was a hard journey. And I can only imagine how difficult it is for people like refugees who had to flee their country, lose everything, sacrifice, their friendships, their families, like their status, their job, everything. And to make this journey to a new life, new environment, where they have to learn a new language. Sometimes they have to stay in these camps for generations. And obviously, like without any infrastructure or sanitation facilities, I just when the pandemic started, I was just like imagining the worst. And I thought, it would happen very quickly, and, it will almost be like, letting these people die. So I thought, we as an AI community can do something with that, with our skills and, the data, the satellite imagery. We can just do some sort of predictions and help, those organizations tackling COVID on the ground to do something smarter and more informed. So hopefully we're achieving this with the tool that we built.
Very good. I think we have Kelvin now joining us as well. Can you hear us okay?
Yeah, I can hear you. Thank you.
Wonderful. Wonderful to see you. Wonderful to hear you. Just in time for your slot. So maybe you can share with us what motivated you to work on your AI project, and the why and the what.
Yeah, I have to say, my grandmother was quite a big influence in my life, and she was quite a very kind lady, the go-to person in where she used to live, and sadly got to a stage where he had to move her in a home, but she said, I don't want to work to move in a care home. I want to stay in my own house. I work all my life to paint my house, and that's my place of heritage, my memories are. And so we left her staying in her own home. And one evening, suddenly, she had a fall, and she broke her hip, and she stayed on the floor for several hours before help arrived. And as a family, it was very difficult because she never really recovered from that fall. It was back and forth to hospital, and a year later, we lost her. And I was in tech, and I felt what we went through as a family. Nobody should go through that. And that's why I basically quit my job and formed My Care, and we use AI to help the elderly to live safely and independently in their own home.
Wonderful. What a great use case. Your sound wasn't great for a while, but I think we can hear you clear now, which is great. So you're joining us from Mauritius today, is that correct?
No, I'm from London. When you from London?
Very good. Excellent. But are you originally from Mauritius?
Yes, I was born in Mauritius, and all my family were in Mauritius. Correct,
Very
yes.
wonderful place. I've worked there quite a bit, so I kept going backwards and forwards quite a lot. Okay, now let's explore the role of artificial intelligence in all your projects, because this is what we're talking about, innovative use cases of AI. It's amazing to hear all the inspiring motivation. So maybe, Hadas, you can start talking about the role of AI in your project.
Can you
Happy
put your
to.
iPad here? Okay.
So what we build is a AI model. We build AI models that are able to analyze and understand medical and clinical text, to understand what appears in the text, what are the relationships, what are the coding systems. We understand conversations, we understand the clinical text, and it allows driving insights from huge amounts of data, from huge amounts of raw text that is out there. This can power queries, and it can allow learning from data, drive insights from this data. We build those NLP models that understand clinical terminology and medical intents. And this allows us to understand what a patient or a doctor is asking and what they need the system to do for them, what kind of information they're looking for, to analyze their intent, to analyze their sentiment. We use content-based filtering and language generations in our expert systems to power those chats and provide relevant answers, relevant content to patients and to doctors.
Very good. That sounds fantastic. What's the role of AI in your project, Greg? What's the role of AI in machine learning in the things you're working on?
Yeah, so with the Folding at Home Distributed Computing project, we have over 1 million devices around the world that are helping us to simulate how all the atoms in a protein move over time. And so as we do this, we're generating tens or hundreds of millions of protein structures. And this is just a massive amount of data to sift through. So we've been doing a lot with deep learning to take all of this data and identify meaningful patterns that help explain how proteins from the SARS-CoV-2 virus work, for example, and how they compare to other proteins, and what sort of therapeutic opportunities we might be able to uncover with all of the structural information that we're gathering.
Very good. So how does that work in practice, the folding from home? So can anyone join this?
Anyone with a computer and an internet connection can join, and what happens is over and over again we give you a structure of a protein, and you go off and your computer will simulate how the atoms move around and bounce off of each other, and then send essentially a number of frames from a longer movie back to our servers, which will then extend. So we're building up all these movies of how the moving parts of proteins evolve, and then we need ways to actually go and extract insight from this and learn something from these massive amounts of data.
Very good. And you run the machine learning algorithms on your own servers, or how does that work?
That's right. So most of the machine learning is done server side. So you can think about what we're doing with all these simulations as equivalent of trying to build a map of this really big, complicated space, and sending out lots of drivers in all different directions and having them send back their GPS coordinates. In this case, the structures of proteins rather than GPS coordinates. And now we're using machine learning to assemble that all into a map of this enormous space that no individual explorer really saw all of.
Very good. That's fascinating. Anyone listening in will also see, or anyone watching us will see, that we have a little banner going across the bottom saying, please let us know if you have any questions, let us know what you think, let us know where you're joining from. This is really good. I'm just looking through the stream, and I've got someone saying hello from France, from Sao Paulo in Brazil, from London, from Pakistan. So this is wonderful to see. What we will do for the first time today is that we will finish this conversation here at some point and then jump onto a Twitter chat. And if you want to join this Twitter chat, you will see the handle going through on the ticker at the bottom. So the Twitter chat handle is @HumansAndAI, and you can join us. So we will continue this conversation and hopefully carry on discussing this on Twitter. Before we do this, we've got lots of other exciting content to cover. So I want to go to Alice and explore how AI is helping in your project. What's the role of AI, and why is it so valuable?
Yes, of course. So for us, AI is obviously not a magic bullet. We understand it's an enabler, so we try to use it where it's necessary. So the idea is to use, obviously, kind of all the state-of-the-art epidemiology modeling available to date, and we use various algorithms to simulate the environment in a refugee camp and predict how the virus will behave in this type of setting. And we basically simulate all the different scenarios. So we run simulations of the outbreak using, different approaches, from the agent-based modeling, which is focusing on, individual behavior and individual movement. So if you know the game called Sims, which probably some of you played in your childhood, it's, basically how people move around, and, by passing by each other, they can, spread or cough or, talk to each other, and obviously, something might happen. So the transmission kind of rate is being affected through the interaction. We also use the network modeling approach, and it's obviously more sophisticated and more complex, but basically it's all about, interactions that we might have in our daily lives. So, the relationships that we have with our neighbors, relationships that we might have with people speaking the same language. For example, queuing for food in refugee camp, you have higher chances to speak to someone who speaks the same language with you, or who might be from the same street as you are. And obviously, the transmission probability obviously is being affected at this point. We also use the basic epidemiology models that are being explored widely in the past year. I don't know if you noticed, but Johns Hopkins and all other authorities in COVID research have been using compartmental models, so focusing on different kind of groups in populations, so people that are being susceptible to the virus, that are being infected, recovered, and asymptomatic transmission is another thing that we had to consider in our simulations. AI is particularly valuable in our case for the curve fitting. So, flattening the curve, it's a common term now that came with COVID. So we're using AI to kind of to fit it and to see kind of the average kind of probability of the spread of the disease, and what is the peak prevalence day in terms of the disease, and how many people may end up being hospitalized, how many people might need ICU units or any special care, and obviously fatalities is another very sad but important statistic for the refugee organizations that we are working with. And the findings from such simulations help our NGO users to decide which intervention strategy to choose and deliver, and when to do it, at what point of the pandemic. So this way they can prepare better and kind of like allocate resources in the right way, in a smarter way. And in the next iteration of our tool, we also plan to use AI to learn the movement inside the camp. So using satellite imagery just to understand how people actually move from one area to another and which areas are more populated. So this will definitely speed up our scaling of our tool to other areas and regions. And we also think we might include weather and seasonality and how it affects the pandemic effects, obviously. So that's it for me.
Very good. And do you use any real-time data from those refugee camps, or do you use a model of them and then you overlay this with data from your simulations? How does that work in practice?
So we do use GIS data. So we need to kind of like make a model of the camp and kind of like put the shelters where people sleep and, stay if they're during the lockdown, for example, if they cannot move. Also like, the food areas, the sanitation areas. So we have to create kind of like a virtual map actually, and then to simulate the movement. So basically put agents in different places. We need to know how many people roughly live in each shelter and what kind of new facilities appear during the virus. So it's not real-time data, but it's being updated very often, so very constantly, I would say even. So we receive kind of new insights from the NGO teams working on the ground. But the idea is actually to create a tool where, you as an NGO can go online, you can input all the parameters. So basically build your own camp the way it is in reality, basically. And then get the data from all the different models in one place. And hopefully it will simplify the modeling part, because right now it's a little bit, ad hoc, and we have to work with the NGO holding their hands, basically explaining the modeling results and stuff like that. So with the tool that we are building, we hope it will be more straightforward, faster. Obviously, AI will help us to enhance the speed, and the results will be more accurate.
Very good. Thank you very much. Now we're going to Kelvin. So you were inspired by the fact that your mom had a fall and couldn't move for basically was on the floor for hours, and you designed a system that helped you with monitoring the elderly. So could we all go on mute if I don't know where the background noise is coming from? That would be useful. Maybe mute everyone. Is there background noise where you are, Kelvin?
Sorry, can you repeat this?
Have you got some background noise where you are?
Yes, there's some background noise there.
Okay, no worries. I just want to make sure I knew where it was from. So, what's the role of artificial intelligence then in your project? So how is AI helping you to better look after the elderly?
Yeah, so basically, humans are creatures of habits. We all follow a certain pattern of behavior. And so we started by using AI to learn about the daily routines of the elderly. And the reason why we did this is because we wanted to shift the whole care model from being reactive to preventative. So we didn't want to wait until somebody has fallen to then call the emergency response. We wanted to use AI to learn the pattern of behavior that we can anticipate a fall, so we can identify the likelihood of a fall, and then we prevent it. The problem that we faced is a lot of the elderly people that we are working with, some of them have cognitive impairment. So what could be abnormal today would become normal in about 2 weeks or 3 weeks. So standard AI using off-the-shelf module was not suitable for us, and that was creating a lot of false positive. And we've had to spend almost a year training our AI, but also using techniques like voting algorithms, where depending on the circumstance, time of the day, it will pick the right algorithms so that we don't create a lot of false positive. And we were focusing on false initially, and people don't fall every time. So the training was quite complex, and we didn't have enough of data to train the model. And we then had to have recourse to different methods of data augmentation, wherein we were creating synthetic data to feed our AI, but we are also working with organizations that have clinical data that they've captured within a lab environment. And then for us, we had to replicate all that into the space of a person's home, where the acoustic was really bad, like mine at the moment. And when you put it into the home environment, the elderly person may have the radio in the background, they may have the TV in the background, they may have the cooker in the background. So all of those sounds we had to filter out. And also we learned a lot, because for us, the minute the elderly shouts, "Help me," the AI needs to respond to that. And there are other products on the market whose name I'm not going to mention now, but they are very popular, where they are recording, listening in the background all the time. We were not allowed to do this because the privacy of the elderly user was very important for us, and because we're also working with healthcare organizations, government organizations, they made sure that we don't background record any speech, because the person might be telling their password over the phone to their bank. So what we do is the AI is listening to sound and converting the sound into spectrograms, which basically machines can understand, but humans can't understand, and that helps us to maintain privacy. But at the same time, it listens to very specific words, like keywords, to then be able to talk back to the elderly and give them the reassurance that help is on its way, and then contact the relevant family members.
Very good. Thank you very much. That's fascinating. Okay, what I want to now do is to explore where you would like to take your project next. So what's next? Where would you like to take your project? What would you like to work on? Who would you like to connect with in the future to make an even bigger impact? So I'm going to Hadass first. So I think developing a chatbot that can help with COVID, that can help with healthcare, is such an important project. So where's all of this going, and where would you like to take it?
We are expanding our health AI services beyond just a chatbot. We're building different types of health AI services in order to expand the ways in which our technologies can help healthcare organizations. And we're looking to grow our impact and build technologies to empower more diverse healthcare organizations, providers, naturally payers, pharma and biotech, and of course, patients. For example, we're building technology to support clinical trials recruitment, not just for COVID-19, although COVID-19 was actually our first deployment of this technology. Clinical trials recruitment is a big problem. More than half of the trials never proceed because they're unable to recruit enough patients to continue the trial. And we started working on that problem, and we're now we brought technology to life to enable that. We're building services that understand clinical and medical texts and are able to extract insight and information from it. We're building further templates to support plasma donation qualification, epidemiological investigations. And overall, we're looking to power more solutions that solve a real need for the healthcare industry.
Very good. Thank you very much. Next, I'd like to go to Greg, working on the protein folding project, crowdsourcing, intelligence. They are all fascinating things. So where do you want to take this in the future? What would you like to work on, and who would you like to connect with in the future? Oh, sorry, you are on mute. Let me unmute you. Okay, now we can hear you.
Great. Yeah, we've worked in a lot of different areas. One of the primary areas we've had impact is, in understanding things. So, what is it that this change to a protein's chemical composition does that increases your risk of Alzheimer's disease or increases your risk of cancer or other diseases. And now we're moving more and more towards really, driving progress by integrating with experiments. So not just extracting insight from the computational models, but really saying, now to test that this is really true. Here are the experiments that you should do to really test this model and refine it, and then increasingly moving into having a practical real world impact by not just testing is the model an accurate reflection of reality, but moving into now here is how you would design a therapeutic, for example, or change the way that you're designing vaccines in order to really tackle problems like the COVID-19 pandemic, but not just COVID-19, because really this is a very general platform, and we're eager to bring it to bear on a wide range of global health problems that can really be thought of as pandemics in their own right, like growing numbers of Alzheimer's cases and antibiotic resistance and other health threats that could become more impactful globally, like mutations to Ebola virus.
I love the fact that you're basically creating data sets that have never existed before, and they can hopefully really advance our understanding of potentially so many other diseases. So how would you then use this data to help develop vaccines, for example? What's the idea there?
Right, so just to give one concrete example, we've been looking at the spike proteins on the surface of coronaviruses. And these are really important proteins because they undergo very dramatic changes in their structure that are essential for the ability of one of these viruses to recognize a host and infect a host cell. And they have different abilities to, evade detection by our immune system, for example, and to actually recognize and infect a host cell. And so we've been trying to understand what differentiates these different capabilities of different coronaviruses, and then now use that insight to say, okay, well, how could I take, the SARS-CoV-2 spike that plays a role in COVID-19 disease, and how could I modify it, for example, to make it easier for our immune systems to detect as a way of improving the efficacy of a future vaccine, for example. So things like this, and then also can be thinking about designing small molecules that would either make the spike more susceptible to our immune system or prevent it from effectively infecting a host. And we can do analogous things with other proteins from this virus or other health threats.
Wonderful. Thank you very much. Okay, let me go to Alice next. So, what's next for you and your work, and where are you looking to grow and connect and collaborate and do more exciting things, even more exciting things in the future?
Thank you. We basically have a lot of ambitions. In the next couple of months, we plan to validate our model parameters with some key academic bodies in the public health and also epidemiology sector, specifically those specializing in low-income settings and displaced populations. We also are looking for partners to test our alpha release, which is due in the end of this month, so very soon, actually 2 weeks left. And we are hoping to engage with as many NGOs as time. We already interviewed like almost 20 NGOs in preparation for this release, but now we want to test the real product and tailor it and build a tool kind of like that will address their needs, hopefully. And finally, we plan to interact with some NGO organizations working in the management, kind of like camp management sector. So basically, those big organizations like UNHCR and others, to see the tool in action and to see how actually we can contain the outbreak. It's very sad to see that more and more cases are being confirmed in different regions of the world. So obviously we need to do something to actually validate that our tool is needed. But most importantly, to save some lives, and it's really important and kind of like number one priority actually. And finally, we are even more ambitious than that. So we want to scale our tool and replicate it, replicate the simulations in some urban slum environments in the poorest regions of this world. So countries like Bangladesh, we wanna kind of like collaborate with some organizations there and just see how we can help and do something to prevent the disaster. So this is the ambition we have set for ourselves, but we think it's doable and we are working towards it.
Very good.
Need help from organizations. So if anyone is open to collaborate with us, please get in touch.
Very good, very good. Hopefully there will be someone listening and wanting to collaborate, because this is an amazing project, and I think extending it to slums and potentially other areas as well. I think there's nothing stopping you modeling cities, modeling countries. You can I guess increase the levels that you're looking at with all of this, and this is definitely something we need. Very good. Okay, let's go to Kelvin. In your work around using artificial intelligence and data to take better care of the elderly and notify people when they have a fall, where do you want to take this? Have you got any ambitions to collaborate, expand your work and push it into new directions?
Yeah, sure. So currently, the AI sits in this cube, and we've named it Monica. And what we found was COVID-19. We learned a lot because the AI is able to identify early symptoms of a pulmonary fibrosis. It identifies when the temperature of an elderly person is going up. So there is so much that we can do in that sector. So we it's there. But more importantly, what we realize is sorry, can you hear me?
Yeah, I think we're losing your feed a little bit. If you could repeat some of this, that would be useful.
Yeah, so what we found is we are collecting a lot of insight from the elderly population as a whole, and we are having some pharma companies that are approaching us and said they'd like to talk to us about drug efficacy, because if you want to try a drug that builds muscle tone to prevent falls, for example, you need to create a purpose-built facility. You do a lot of tests on the elderly person, and then you bring them to this new facility to identify whether your drugs are effective. And what we have is the ability to keep the person in their own house, and are administered by the GPs, general practitioner, and then we can monitor the person in their own house. And in terms of liability for the pharma company, this is really useful. But we are also now learning and capturing data that are giving us trends. As an elderly person move through the cycle where they start to have some multimorbidities and where they end, and we're using data to inform people that are entering that cycle, so we can help them to prevent the progression of certain long-term conditions. We're having a lot of children of the elderly that said, uh, we want to use that data to help us understand whether there are any genetic aware
Sorry,
if
we're losing
mum.
you. So if you can repeat the last 30 seconds, that would be useful.
Sure. We're also having a lot of children of the elderly that are approaching us and saying they would like to have access to the raw data, because if let's say that mom or dad are diabetic, then they know that they probably end up being diabetic, and they want to learn from the data collected about their parents so they can influence their own health and well-being. And that is becoming fairly big for us. But we are also talking to insurance companies now who would otherwise not insure an elderly person because they see them as high risk. And so they are placing the cubes into the home of the elderly, identify their whole behavior, how they keep healthy, to then basically readjust their premium. And that is helping us now to go global. And we are working with one of the leading professor neuroscientists in University of Arizona, who is really helping us to understand from a neuroscience perspective, how do we use our to help people with mild to severe cognitive impairment, and how to get the cube to address them. And one of the example I use a lot is the cube don't tell them please drink, because if you tell an elderly person go and drink, they won't do it because they feel they're being patronized. What the cube does instead is, hey Pam, or hey Doris, I'm feeling really thirsty, how about you? And that triggers the neurons in the brain, and they decision. So these are the areas that we are perfecting at the moment, so we can and focusing in the area of but also shifting to the younger generation.
Very good. I think we missed a few little bits there, but this is fascinating. Thank you so much, Kelvin. A very worthwhile project that you're working on. Very worthwhile projects you're all working on. So thank you so much for sharing this with everyone today. What we said is we would know. Instead of us answering questions here, because this is what I would normally do, today we are doing it slightly differently. We will head to Twitter, where you can now join us, and the Twitter handle is @humans&AI, that you can see going on the ticker. And there you can join us for a Twitter discussion where we will all join in. So if you go to my Twitter page, or you just type in the hashtag, you should be able to join us, and we will carry on those discussions there, and hopefully answer as many of your questions as you have posed. The other thing we'll do is we will have a look at some of the questions you have put into the chat today, and I will try to answer as many of them as I can, or forward them to the right people to get them answered, so we make sure that all of your questions get answered. So thank you very much, everyone. I really hope that was useful. I found it fascinating. Thank you so much, Alice, Hadders, Kelvin, and Greg. Wonderful stories. And I will hopefully see you all on Twitter.